before I jump into using Pillow, I want to talk a little bit about images and image formats because it's useful to know a little bit about how images are stored and the kind of data that they represent, so you know what you're doing when you're editing images. So there are three basic image types that we will be dealing with as we dive into this, and they're probably the three more common types that you're going to encounter out there, especially on the web. Um, all of these in one shape or another, or one way or another, are connected with the web, and they are really designed to provide the best looking images uh, for the smallest file size. Because even now, but especially in the earlier days of the web when we were all on really slow dial-up modems, that extra file size really made a difference. And a lot of the file formats that we had up to that point were what we would call uncompressed file formats, or raw data, or a bitmap is a common format, a TIFF, a tagged image file format. You might have still seen those floating around here and there on your computer. But once we started talking about how can we send these images over the web, over the internet, more efficiently and have them still look good, we really started thinking about how can we compress the file size, make it take up fewer bytes, and have it still look okay. So these three are all different, basically mathematical formulas for storing the data of how an image looks in a way that takes up less space than if you describe each pixel of the image. And so when we're talking about images, we're talking about just a grid, right? Oh, that's a very bad pen. Let me try that again. We're talking about a grid. All images are basically square, but we're talking about a grid where the image is divided up into what are called pixels. And if you do what your parents told you never to do, and you look really, really close to your screen, you can see the individual pixels on your screen. And so every image on a screen is basically made up by coloring in pixels with different colors. And so each pixel of an image is tagged with, at a minimum, a color. So it's 256 or 255, 255, 255. That's an RGB image, red, green, blue, all at full strength. Okay, 255. Every image, every pixel has three color channels at a minimum, sometimes four, one for alpha transparency. We'll get to that later. But all you need to know is that each of those channels has between 0 and 255. If I turn them all up completely, then that makes white. If they're all turned all the way down, 0, 0, 0 is black. And you have every combination in between. Basically, 255 to the third power, which is about 16 million different colors. Okay, so we have lots and lots of different color possibilities. 16 million sounds like an awful lot, but that's just a small fraction of what your eye is capable of seeing, by the way. So even when we have a really great picture, a great photograph, it's never as good as what your eyes can see in nature. Just interesting side topic, maybe. So when we have a bitmap file, a raw image, we have to describe each and every pixel at a minimum of each of those color values. And, this is a low resolution image here. When we're talking about megapixels, we're talking about millions of pixels. And when our phones, the little computers, the magnificent computers we carry around in our pockets, can take one photo with 16 million pixels, all of these numbers start to add up. And they make very big files. And so there's a real interest because storage even if we're using a faster internet connection than we used to, which we are, storage still matters. The size of an image still matters. So we're still using compressed image formats. I'm just going to give you a real quick primer on these three so you kind of have an idea of what's going on behind the scenes. Graphics interchange format, famously known as both GIF and GIF, I'll cater to everybody today, is a format that is not that great looking, but it is one of the more compressible formats. It is especially compressible when there are large blocks of the same color or a small number of colors in the image. The reason for that is that a GIF file indexes the colors, so it takes all of the 200 most common colors in an image, the most commonly used by pixel, and it takes all of the pixels in the image and it makes them one of those colors. So it has an effect that looks like what we call posterization, which is a fancy way of saying it reduces the number of colors in the image. So if you have a gradient that fades really beautifully through the colors of the rainbow, that's going to get changed to stripes of colors. That's the easiest way to tell if a image has been color indexed, because it reduces the number of colors in an image from a possible 16 million to 150 or 200, or depending on the level of compression. Okay. The other thing that GIF does really well, as we all know, animations, perfect for making memes of all your siblings or whatever, sending them to your friends. I have entire conversations with some of my kids that are nothing but memes. And the other thing that GIF did early on is transparency. And that was pretty miraculous, because before, this is my walking uphill to school both ways in the snow story for you all. In the early days of the web, we did not have images that could have alpha transparency. It's not possible to have an image that's 50% transparent, that you can kind of see, but you kind of see through it. What we had is GIF files, and what you can do is you can designate one of the colors in the image as being transparent. So it's a clunky solution. It's a low resolution solution, and there's no such thing as fading from visible to invisible. You either see it or you don't. So that is how transparency in a GIF file works. It takes one of the colors in the index and makes everything that's that color in the image transparent. It's limiting, but it's very compact. Okay, it's the most compact way to animate anything on screen, still with the exception of maybe some kind of scripting solution using SVG files, scalable vector graphic files, because those are actually smaller than GIFs. But I digress. JPEG. JPEG is, as the name suggests, a file format that is really strong for photographs. GIF files are great for logos, great for cartoons, great for anything, again, few colors or large blocks of color. JPEGs handle a huge variety of colors and images with a lot of variation in color a lot better than GIF does, okay, because it does not posterize. What it does is a process called interpolation. It basically takes groups of pixels and averages them to a single color, which allows for a smaller number of data points to represent a picture. The result is what's called artifacts. And if you've ever seen a low quality photograph, you probably know what I'm talking about. It's just got like crap in it, noise. And so that's where interpolation happens. Another place where you hear about interpolation, this used to be impossible, by the way. 20 years ago on CSI, they used to have like the grainy, blurry cam photo of the suspect taken from a security camera half a mile away, and they'd be like, their face would be literally like a blurry dot, and they'd be like, let's enhance that, and all of a sudden you can see every pimple on their face. That's not something that they can even do now in real life, not to that level, but using artificial intelligence and interpolation, they can actually take those pixels and draw new pixels in between them, guessing at what that shape should be or guessing at what that person should look like. And it's getting better and better. It's a little freaky. So can we get that level of detail from that bad of a photo? No, but can you take something that's kind of blurry and enhance it? Yes, you can. And you can do it using an app that's downloadable on your phone now. It's not like you need a supercomputer for that. Portable network graphics is a newer format than the other two. It's a better format than the other two because the mathematical formula that it uses is called lossless compression, which means it is using advanced math to reduce the file size without messing up the quality of the photo or the image. It's good for logos, it's good for photos, it does almost everything. The end result file size is slightly larger than either GIF or JPEG. But if you can tolerate a slightly larger file size, your quality improvements are huge. So most of the work we'll be doing in this class will probably be either JPEG or PNG. I'm not going to mess with GIF files too much. They're just too low res and they're too weird. But those two I will be playing around with, depending on the piece of code that we're looking at.